In this lesson, I want to talk about cutting on different planes on a CNC milling machine. For that, we use G17, G18 and G19 G codes. This diagram makes it easier to visualize where each plane is. Our G17 plane is our usual cutting plane on the X and Y axes. This is the plane that the machine defaults to. If we don't enter a G17, G18 or G19 G code into the program, the machine automatically assumes we are in G17 mode. The G18 plane is used when we're cutting arcs on the X and Z axes, and the G19 plane for when we're cutting arcs on the Y and Z. A typical line of program would look a bit like this using one of these G codes. Taking the first line as an example, the G17 tells the machine what plane we are cutting on. The G02 is our clockwise move, X and Y is positional moves, our R is our radius, and a feed rate at the end. To change between different planes, we simply add the different relative G code at the beginning of the line. So, the machine always assumes we're in G17 mode unless we state otherwise. If we are programming with multiple planes, it's best to state the G17 G code at the beginning of each section of program, normally somewhere after the tool change. This is to stop the machine from accidentally cutting in the wrong plane if we jump into the program to recut with a certain tool. A typical safety line after a tool change would look like this. G90 tells the machine we are using the absolute system. G54 resets our datum. G21 tells the machine we're in a metric, and G17 tells the machine what plane we are using. Let's have a look at each plane in relation to which way the G02 or G03 command works. Now remember, G02 is our clockwise interpolation of cutting an arc, and G03 is our counterclockwise. This is a graphical representation of the G17 plane. The G18 plane would look like this, and the G19 plane. These last three slides are available for download underneath this lesson. So let's have a look at a sample program of how we use this in real life practice. For this example, I'll start with the G17 plane. We start off with N1, our search number, and tool 01 with offset 01, and our operator's note of a 10mm end mill. M06 is our tool change command. This will give us an automated tool change if the machine is capable. Next we have a block of code which I refer to as our safety line. G90 tells the machine that we're using the absolute measuring system, G54 calls our datum, and G21 tells the machine we are using metric. G17 can also be added to this line to tell the machine that the rest of the block of program will be using the G17 plane. Our S value sets our spindle speed of 2000 RPM, and MO3 turns the cutter on in a clockwise direction. And we now move our cutter into position using the rapid command of G00. G43 turns on our cutter compensation, Z10 brings the cutter down to 10mm off the face of the material, and MO8 turns on our coolant. Using a G01 feed rate command, we now bring our Z down 30mm past the face of the material with a feed rate of 50mm per minute. Now we get to our G17 line. Adding a G17 before a radial move tells the machine which plane we wish to cut the radius in. If we were cutting on the other two planes, we would add G18 or G19 in place of our G17 here. So G17 selects a plane, G02 selects our clockwise radial motion, X and Y are positional movements, R is our size of our radius, and finally F is our feed rate. Since our component has no dimensions, I won't bother going over each line of our dimensional moves. The machine already knows we're in G17 mode, but I've stated it again on this line, followed by the G03 counterclockwise move to bring the cutter back in the opposite direction to cut the radius. Using G00, I rapid away from the material 10mm above the face of the part, and using MO9 to turn off the coolant. G53 tells the machine we wish to use the machine datum, X, Y and Z takes it back to the machine 0 point, and MO5 turns off the cutter. G40 turns off our cutter compensation, and M30 tells the machine the program is finished and to rewind back to the start. So, the same part using the G18 plane would look like this. It's almost exactly the same program, apart from the line where we use our G02 to cut our radius. We use the G18 command beforehand to tell the machine which plane we are cutting in. You'll notice, after we've cut this plane, I'll go back into the G17 mode on the line below before we start the rest of our milling. If this G17 wasn't there, the machine would probably alarm out. Worst case scenario, it would think it's on a different plane and cut in the wrong direction. But in my experience, the machine normally alarms out. And that concludes our discussion about planes on a milling machine.